Okay, this video is going to be about stairs. Um, I don't know how at this point in the course, I don't know how far we're going to get into calculating stairs. I got to relook at that. But you have a variety of different stair types and patterns. Okay, you've got just your regular straight stair, and then you may have a straight with a platform in the middle. Okay, if you think about houses, it's unusual to have a landing or a platform in a set of stairs, but in commercial buildings, you must have a landing um, every so many vertical feet. Okay, so that people can rest that need to rest. Okay, whereas in a house, if you have a change in direction, like here we have an L-shaped stair, typically we put a landing at that intersection. Okay, because it's easier to negotiate that stair. We can have a winder of one or two steps in that landing, but it makes it more difficult to go up and down because once a person starts climbing a set of steps, by the time they hit that second and third step, their body has kind of memorized the pattern, and it makes it that's why it makes it easy, negotiating steps. They all have to be the same size, the treads and the riser heights. Okay, they all have to be the same size. And when you introduce a winder or a curved stair, it makes it more difficult to negotiate because now your body has to change when it hits that landing. Um, some terminology: treads are what you tread upon. It's what you walk upon. Okay, it is the horizontal surface. The riser is the vertical surface. Okay. Uh, oh, I didn't go through and edit this one. Okay, so stairs. A minimum stair width is going to be 36 inches. Uh, there are some exceptions to that, but we pretty much go with 36 inches. The tread, the depth of the tread should be between 10 and 12 inches. And 10 and a quarter, 10 and a quarter, 10 and a half is kind of the norm. Okay. Now risers can range in height, okay, from 4 to 7 and a quarter inches. The angle is not so much is not critical because when we lay out and calculate stairs, we don't use the angle. Okay, we use something else because there's a relationship between the tread and the riser. The shorter the riser, the longer the tread needs to be. So if we were to use a 4-inch riser height, now our tread really should be somewhere close to uh, 12 to 14 inches. Okay, because if you think about the gait of walking, when we're walking on level ground, we take a longer step. Like you know, most people a normal step would be like 30 inches every time we step. But when we start going uphill, we take shorter steps. Okay, now we're climbing stairs, which are relatively steep, compared to normal ground. So we're taking even shorter steps. So we're taking like a 12-inch step the higher we have to climb. And so when we have a lower incline, we can take a longer step. So there's a relationship between tread and riser. And we'll get into that more if we when we talk about calculating stairs. There's a slide in here. I'll show you a little bit about it. There must be a clear head height of 6'8" clearance all throughout the stairs. Okay, it's just like a door height, and that is measured from the nose of the tread that sticks out. Okay, handrails and guardrails, 36 inches. And there's additional uh, criteria on handrails as to how they cannot stick out more than a certain number of inches from the wall, and the ends are supposed to be closed off so that nothing could get hung, like you're trying to hurry, down the stairs, and you don't want your purse strap or a piece of clothing or something to get hung on the end of the handrail. So there should be closed off. Okay, design formulas, there's um, a number of different formulas. And when we kind of get into that section later in the course, I will give you the one that we're going to use because there's some test questions on it. Uh, but there's the one that I typically have used the most in the past is the riser plus a tread. Should be somewhere between 17, 17 and a half inches. So if we were to take one riser height plus one tread depth, they would equal this amount. So if we have a 7-inch riser, a 10 to a 10 and a quarter inch tread would be the optimum stair size. Okay. And we're going to get more into how to design and lay out stairs uh, later on. We will do that later on. So as far as the floor plan goes, I think I tell you in our floor plan videos to draw your uh, stair risers at like 10 inches. And that's just to get us started with our floor plan. And once we've calculated stairs, we'll come back and edit that and modify it because we need to know the height of our building before we can calculate the size of the stairs. But we would annotate on the floor plan with a note D N for down, UP for up, and R would be risers, would be the number of risers. Um, and in our stair layouts and drawing them, there's always one less run than rise. Okay, which meaning when you think about a set of steps, you start with a riser and then you end with a riser where the stair meets the floor at the next level up. So if you're counting them, there's always one more riser than there are treads. Okay. Um, stair length, tread. Okay, yeah. And so what we're going to do, we're if you had open stairs where you had a railing and a guardrail, you would do a note for that. Our plan is enclosed, so there's walls on both sides. I can't remember if we're drawing rails or not. We can, but we will draw an arrow indicating the down direction. Okay, in our floor plan that we're going to draw.